So I hope my screen is visible to you. My audio and video is clear.
Yeah,
Okay, right.
it's visible.
So once again, I'm happy to be back for this object-oriented programming. So today's class will have a short introduction to object-oriented programming. Of course, you know about object-oriented programming. It's all about C and C++. This particular class will discuss in detail about the various programming characteristics of object-oriented languages. Today we will be discussing much more about C and C++. And of course, this is dedicated for you and only for you, my dear students and young researchers. And you can reach me at dr.christoananth@gmail.com. So before beginning the session, maybe any number of sessions, don't forget to thank God. As for me, once again, I thank God for giving me this golden opportunity to deliver this useful session of object-oriented programming to share my knowledge among my fellow national, international participants, students, and young researchers. Okay, so today's class will discuss much more about an introduction, a short introduction about object-oriented programming and why the C++, which is an extension of C, it's a partial object-oriented programming. Or we'll discuss much more about the various classes, various objects, the encapsulation process, or maybe the polymorphism process. You know, the how the tree is being developed in C++, and how inheritance class works in C++. Of course, we'll discuss about dynamic binding and message passing, and we'll have the advantages of OOP, object-oriented programming, and then we'll define C++ objects, accessing the data members, and then we'll discuss about the base and derived classes. We'll discuss about the base class shape and its derived class rectangle. We'll discuss about the various types of inheritance, the data encapsulation in C++, and then we'll have some independent work. I've already posted the independent works in the Google Classroom, both for object-oriented programming as well as for advanced programming practice. Please have a note of them. And as promised, within today, I'll be uploading the syllabus in the Google Classroom. Okay, so you can have a note on the syllabus, the materials, as well as the independent works. Of course, at regular intervals, I'll be giving you some short videos to keep you active about and updated about today's topic. So this is a short introduction to object-oriented programming. So which means that object-oriented programming, which means that it uses objects. Okay. So here in object-oriented programming, we tend to implement some characteristics called inheritance, hiding feature, polymorphism in programming. Okay. So the main aim of object-oriented programming is to bring the data together and the functions which operate on them so that no part of the code can access this data except that function. For example, if you have object-oriented programming, it is nothing but a combination of maybe classes, objects, abstraction, encapsulation, polymorphism, and inheritance. So what we do in today's class, we'll discuss about each of the characteristics in detail. Now we'll analyze why C++ is considered to be a partial object-oriented programming. When C++ was being introduced, the main intention was to enhance the object-oriented features. So that's the reason we go with object-oriented programming, where C++ supports classes, objects, inheritance, encapsulation, abstraction, and polymorphism. Okay. So there are some reasons why C++ is called to be an object-oriented language. Okay, because first thing is that whether it may be creation of classes, whether it may be creation of objects, it's actually optional. We can or we need not have to. In C++, the main function is mandatory, which means that it's always outside the class. Okay, so we have only main function, main function. Okay, without classes and without objects. So this is actually the first violation of the pure object-oriented programming language, where everything is being identified as an object. Okay. And the second thing is use of global variables, not local variables, but global variables. Global variables which means it is declared outside the program and it can be accessed by any other entity of the program. So which means that it clearly violates encapsulation process, because encapsulation process is all about local classes, local objects. So since it takes impact of the global variables, it violates uh, encapsulation. Okay. But still you can say C++ supports encapsulation with respect to the classes and objects, but it doesn't take care of it in the case of the global variable. So whenever it uses global variables, it doesn't take care of the other classes and objects as well. And then presence of a friend function. So C++ supports a friend class or function that can be used to access private and protected members of other classes by making them a friend, which means that everybody are associated, every function is associated with C++. Once again, this is going to violate the object-oriented programming practice. And then we'll discuss about the classes, several classes of C++. So here, when you consider the building block of C++, so with the case of the classes, if you can see in C++, it is considered to be the essential building block, where we have the user-defined data type, which has several members and member functions that are associated. So this C++ class is actually a blueprint for an object in an object-oriented programming. For example, let us consider an example. Consider the class of cars, which means there are several cars and every car has its own name and a brand model. But still, they will have some common properties. Maybe four wheels. So there is nothing that a car can have like two wheels. Every car has four wheels, and every car has speed limit. Every car has mileage. Okay. So here the car is considered to be the class, whereas wheels or maybe speed limit or maybe mileage are the properties. So a class is a user-defined data type, whereas we within the class we have data members and member functions as well. So here the data members are data variables and member functions are the functions which are used to manipulate these variables, and together these data members and member functions will together define the properties and behavior of the objects in the class. Okay, so this is all about C++ class. So as I told you, classes are considered to be the blueprint of the objects. So an object is an identifiable entity with some characteristics and behavior. Or you can say an object is an instance of a class. So when you define a class, there is no special memory that is allocated. Okay. So, but when that object is being created, okay, only during creation of the object, some amount of memory is being allocated. But when you define a class, no memory is created. Only if you create an object, some special memory has been allocated. So here is the object in C++. You have class person, character name of 20 characters long, int id. So the public void get details. Okay. And then you close the brace, int main function, person p1. So person p1 is considered to be the object over here. So this is how you include the the objects in C++, person p1. So object, definitely it can take a space in the memory and it can have an associated address like a record in Pascal or maybe structure or maybe union in C. So when the program is executed, the objects interact by sending messages to one another, and each object contains data and code to manipulate the data. Okay. And the objects can interact without having to know details of each other's data or code, and it is sufficient to know the type of message that is being accepted and the type of response that is returned by the objects. And then similarly, we have encapsulation. Encapsulation is defined as wrapping up of data and information under a single unit. Okay. So in object-oriented programming, encapsulation is defined as binding together the data and functions that manipulate them. Encapsulation, we have some examples. Maybe in a company there are different sections, maybe like account section, finance section, sales section, and so on. Maybe in finance section you will have all the financial transactions, and you will have all the data that is related to the finance. Sales section, sales related activities you have, how much sales have gone through, how much sales haven't gone through. You will have all this information. But when for some reason an official from the finance section needs all details about the sales in a particular month, he is not allowed to directly access the data of the sales section, which means he has to contact the person. Okay, some person in charge of the sales section, he or she has to contact, and then he has to request the data, particular data. So this is actually encapsulation. So you cannot directly access another section, but you have to request it, and then they will grant access, and then you have to get access to whatever you want. So this is what you call it to be encapsulation. So here the data of the sales section and the employees that can manipulate are wrapped under a single name called as the sales section. So here this is encapsulation C++. Within encapsulation, or maybe within the class, you have methods and then we have variables. So encapsulation, definitely we will have like data abstraction or hiding. Okay, so you have to request, only then you will get the details. So which means it is data abstracted or maybe hiding. Okay, so as using encapsulation also hides the data. In the above example, the data of any of the section like sales or maybe finance or maybe accounts are hidden from any other section. So this is abstraction. So data abstraction is considered to be one of the most essential and important features of object-oriented programming in C++. So abstraction means displaying only essential information and hiding the details. Okay. So data abstraction, it's generally very useful for the object-oriented programming, but abstraction is hiding the details. So you provide only the essential information about the data to the outside world, but you hide the background details. For example, if somebody requests the sales details of that particular month, means like you need not have to showcase everything, okay, to the requested user. Okay, you have to showcase only the part that is actually required. Other things you can hide it. For example, let us take in the case a man is driving a car. A man only knows that pressing the accelerator will increase the speed, or maybe if you apply the brake, it will stop the car. But he does not know about how on pressing the accelerator speed is actually increasing. Okay, that inner mechanism he doesn't know. Even when you press the brake, and immediately car stops. But how the process acts, he doesn't know. Okay, this is what you call it to be abstraction. Simply you can say data abstraction. So you can use abstraction with the help of the classes, and we can implement by specifically using a class. So you can say the class helps us to group data members and member functions using available access specifiers, and a class can decide which data member will be visible to the outside world and which is not. Similarly, abstractions can be used in header files as well. You can consider the par method, which is present in math.header file, and whenever we have to calculate the par of a number, we simply use the par function, par within braces, which is present in the math.h header file, and you pass the numbers as arguments without knowing the underlying algorithm in calculation of the par of the numbers. So before going into, yeah, there is only some more slides. We continue. So then we have like polymorphism, which has you can define polymorphism in different ways. So polymorphism is the ability of a message to be displayed in more than one form. Okay, so which means that a person at the same time can have different characteristics. Okay, maybe like if I'm a human being, I can be a father to my daughter, I can be a husband to my beloved wife, I can be an employer, I'm sorry, I can be an employee to my organization, maybe I can be a part-time worker for another company. Okay, so the same person definitely will possess different characteristics, different behavior in different situations. For example, I cannot be the same as I'm working in an organization, or maybe at home also. Maybe at home, maybe I'll relax more, but in organization, I have to be uh, more mature enough to handle tasks as well. So this is what you call it to be polymorphism. Same thing but different characteristics. So here in C++, we have operations which exhibit different behaviors at different instances, and here with the help with the instant characteristics which is present, we have operator overloading as well as function overloading characteristic, which is an essential polymorphism characteristics which is presented in C++. In operator overloading, we make the operator to exhibit different behaviors in different instances. What you call it to be operator overloading. And in function overloading, you use the single function name to perform different tasks. Okay. So this is what you collectively exhibit the polymorphism. So this is an example. Suppose let us take in the case we have to write a function to add some integers. So there are two integers and sometimes there are three integers. We can write the addition method with the same name but which has like different parameters. Okay, let us take in the case int main function. Sum1 is equal to sum 20, 30, and then sum2 equal to sum of 20, 30, 40. The same thing we can generalize the function. For example, int sum int a and then int b and then return a plus b, or else you can do the same as int sum of int a comma int b comma int c, and similarly you go with return a plus b plus c. Suppose if you add two numbers, you can do this one. Suppose you have to add three numbers, you can do this one. So this is according to the parameters, generalized version of the parameters. So here we also exhibit a characteristic called inheritance. So which means that it's actually the ability or maybe the capability of a class to derive properties and characteristics from another class. So inheritance, it's considered to be a very important feature. We have like subclass, superclass, and reusability. With the case of subclass, which inherits properties from another class, generally it is called subclass, which means that the same properties you will have from another class, which means it is a tree. Okay, from the ancestor, from the parent comes the son or the daughter. It's a subclass. And then superclass, the class whose properties are inherited by the subclass, called as the base class or the superclass. So this is the base, this is the foundation from which everybody tries to follow. And then reusability. Inheritance supports the concept of reusability, which means that whenever we want to create a new class, there is already a class which includes some of the code we want to, and we can derive a new class from the existing class, which means that we are reusing the fields and methods of the existing class. So for example, let's take in the case of an animal class, we have dog class, cat class, and then cow class. All belongs to animal, but there are different classes. But dogs, cats, and cows, everything has been evolved from animals, which is considered to be the base class. Now we discuss about some two important functions of C++, which is dynamic binding and message passing. So here in dynamic binding, we have the code to be executed is actually resided in runtime, which means that similar to what we have in Django, we have the virtual functions, the virtual environment functions as well to support this. And similarly, we have message passing function, which means that the objects communicate with one another by sending information and receiving information to another, which means that we are passing a message from one end to another end. Here, a message for an object is a request for execution of a procedure, and definitely it will invoke a function in the receiving object to generate the desired results to the sender. Okay, so this is how the message passing process acts, and it involves by specifying the name of the object, the name of the function, and what is the information that has to be sent. Okay, so this is dynamic binding and message passing. So here in dynamic binding, here the code is executed at the runtime and there are virtual functions. Message passing from one end to another end, we are passing the message for an object. We will have the object name, function name, and the information to be sent. Here there are several advantages of using object-oriented programming. We have a concept called reusability, which means the same code can be reused through the inheritance, and we can easily acquire the existing functionality and we can improve it. We need not have to rewrite the code once again, which means it's a less bloated code. And it's a modularity as well. We modularize the program in object-oriented programming, and it's easy to modify or troubleshoot the program if the problem occurs, or maybe a new feature or enhancement is to be added. Okay, so modularization generally gives you a transparency of code clarity, and definitely you can read the code at ease. Okay, so you can read it, you can modify it, you can troubleshoot it whenever there is a problem. And then it is flexible with the polymorphism characteristic. So polymorphism, as I told you, it can take several forms. We can have like operators, or maybe we can have functions that will work with several objects. Definitely it allows us to save us a lot of time whenever we write different functions for each object. And maintaining the code with object-oriented programming is very easy, because it's very easy to add new classes, very easy to add new objects. So there are not much more changes. So it's easy to maintain the code. Even with the abstraction feature like data and information hiding, object-oriented programming helps us in data hiding, thereby keeping the information safe from leaking to others. Okay, so only the data that is required for the smooth functioning of the program are exposed to the user by hiding intrinsic details. Now we go in detail with the C++ classes and objects. So the main purpose of C++ programming is to add object orientation to the C programming language and classes. So here the classes are used to specify the form of the object, and it combines data representation and methods for manipulating that data into one neat package. So here the data and the functions within a class are called the members of the class, and when you define a class, you define a blueprint for the data type. Okay, so which means that you need not have to define any data, but it does define what the class name means, what is that object name, what that object will consist of, and what are the operations that has to be performed on that particular object. So this is all about how you define a class, how you define a blueprint, and what are the data that has to be decided to that class. Now we go into the class definition. So here within the class definition, we have the keyword called class and then box. Okay, the class name is actually the box, and within the class body, okay, we'll have a set of pair of curly braces. Okay, so class definition must be followed either by a semicolon or a list of declaration, like for example double length, semicolon, double breadth, double height, and then semicolon. So double length means this is actually the length of the box specified in double type, breadth of the box in double type, height of the box in double type. Okay, and afterwards you close with a closing brace and then semicolon. And with the case of defining C++ objects, you define a public keyword which determines the access attributes of the members of the class that follows it. Okay, maybe you can have a private class or maybe protected class. Okay. So for when you are going to define C++ objects, it will have like two objects of the class box. For example, box 1, box box 2. So box 1 means it's going to declare the box 1 of type box 2 of type box. Okay, so both these objects, box 1 as well as box 2, will have their own copy of the data members. So box 1 will have its own set of members, box 2 will also have its own set of members. Accessing the data members. So how you are going to access the data members? So in the C++ program, you go with hash include iostream using namespace std function, class box. Within that, you go with public, okay, either public or private as well. So public, double length, double breadth, double height, and then the int main function box 1, box 2. Okay. So afterwards, you go with double volume equal to 0.0, which means that you are going to store the volume of the box here. And then box 1 dot height equal to 5.0, you are going to declare it, maybe initialize it. Box 1 dot length equal to 6.0, box 1 dot breadth is equal to 7.0. Similarly, box 2 specifications, box 2 dot height 10, box 2 dot length 12, box 2 dot breadth is 30. Okay. And afterwards, you go compute the volume of the box. Volume, of course, you know it is length, breadth, height, L into B into H. Okay. L multiplied by B multiplied by H. So it is box 1 dot height multiplied by box 1 dot length multiplied by box 1 dot breadth. And you are going to print the volume of the box 1. Okay, so see out volume of box 1. This is actually volume and then M. And volume of the box 2. Similarly, length multiplied by breadth multiplied by height. Okay, simply you are going to print the volume of the box 2 and then finally return 0. So when it is being compiled and no error, and again it's being run executed, it will print volume of the box 1 is actually this one, 5 multiplied by 6 multiplied by 7. So you're going to do that. Okay, and there's volume of the box 2 as well. Okay, so you're going to multiply it and you're going to get the result. It's easier to create and maintain an application, which means that you have an opportunity to reuse the code functionality which is being used in the parent class. You can reuse the code functionality, you can reuse the implementation time as well. So your time is being saved, so that's the advantage of Encapsulation. So when you are going to create a class, instead of writing completely new data members and member functions, the programmer can designate that the new class should inherit the members of an existing class, which means that the existing class is called as the base class, and now the new class which is being derived, like in the previous example, we have the bank in the 90s, bank in the 20s. So bank in the 20s were able to derive from bank in the 90s, so it is considered to be the derived class. Whereas bank in the 90s is considered to be the parent class or the base class. So here are the base and the derived classes. So generally we will have like class, derived class, and then the access specifier, base class. So the access specifier can be public class or maybe protected class or private, and a base class is actually a previously defined class. Okay. So if the access specifier is not used, then definitely it is a private class. So this is the base class shape and its derived class rectangle. So in the hash include string using namespace std function. In the base class, you define the class shape, public, then void set width in w, and then width you are going to specify it as w, and then void set height. We are going to initialize the height. So height is equal to h, and now in the protected class you go with int width and int height, and then after defining this base class you go with the derived class. Now everything has been pre-initialized. Now you go with the derived class rectangle, public shape, and in the public int get area you are going to return the width multiplied by height, and you close all the braces. Okay, and then you go with the int main void function, rectangle rect, and rect dot set width. You are going to set the width. You are going to actually initialize, get the area width multiplied by height, and afterwards you are going to set the width of 5, set the height of 7, and you are going to print the area of that object. So total area is actually rect dot get area. Okay, and then you are going to return 0. Now when it is being compiled, when it is being executed, so similarly when you see over here 5 and 7, so width multiplied by height, it gives the total area to be 35. Okay, so this is how you go with the base class shape and its derived class. And then you have some features of both access control and inheritance. So derived class is accessing the non-private members of the base class. So base class members that should not be accessible to the member functions should be declared private in the base class. So which means that if the access is of the same class, then public, yes, we can access it. Protected, yes, and private, yes. But derived class means the public and protected, it is yes, but private as of base class, it is no. Outside classes means public, it is yes, but protected and private, it is no. So derived class, it is going to inherit all the base class methods, and there are some exceptions. So here the constructors, destructors, as well as copy constructors of the base class, overloaded operators of the base class, and then friend functions of the base class are inherited from those. So there are some types of inheritance. We already discussed this one, types of inheritance: public, protected, or private inheritance. So we hardly use this protected or private inheritance, but public we commonly use it. Okay. So when deriving a class from the public base class, public members of the base class become public members of the derived class, and protected members of the base class become protected members of the derived class. So whatever is derived from the base class, it becomes for the derived class as well. So base class private members are never accessible directly from a derived class, but can be accessed through calls to the public and protected members of the base class. So we have protected, private, as well as multiple inheritance as well. So when you are going to derive from the protected base class, there is public as well as protected members of the base class become protected members. And in the case of private inheritance, when deriving from the private base class, public and protected members become private members of the derived class. And there are cases of multiple inheritance as well. So a C++ class can inherit members from more than one class, which means that we have class, derived class. You access the base A as well as base B. So here the accesses can be public, protected, or private, and it can be given for every base class. Okay, comma followed by comma access base A, comma access base B, comma access base. Okay, so you are going to access it from different bases. So this is an example of multiple inheritance. Hash include IO string using namespace std function. So in the base class shape, you are going to go with class shape public, void set width int w, width equal to w, and void set height int of h, height equal to h. And then this is actually public class. This is protected class. Normally this protected class is rarely being used. Normally for multiple inheritance is being used. Protected class int width and then int height. And then the base class paint cost, you are going to go with public int get cost, int of area. So the area is taken into account for the total cost. Return area multiplied by sum. So you are going to multiply with the cost. And in the after doing this one for the base class, you are going to go with the derived class. Okay, so class rectangle, public shape, public paint cost, and within the public int get area return with multiplied by height. And int main void function rectangle rect int area, and then rect dot set width of 5, rect dot set height of 7. Okay. So what you are going to do, you are going to get the area equal to rect dot get area. So this is the function which we explicitly use for getting the area, and you are going to print the total area, okay, and print the total cost of the painting. Okay. So when the above code is being executed, so it is going to print area. So area is actually 5 multiplied by 7 is 35, and total paint cost is actually 35 multiplied by 70. So you are going to get as 2400. Finally, we come up with the data encapsulation in C++. So here in C++ programs, we have a set of codes, we have program data, we have encapsulation as well. So code means it's actually a very important part of the program which performs actions, and what you call it to be the functions. And in program data, we have the data, which is nothing but the information of the program, which gets affected by the program functions. So code is what you do to perform actions, what you call it to be functions, and data is the information of the program which gets affected by these code or maybe the functions. And this encapsulation is, as I told you earlier, maybe at the start of the class, it is bringing together the data and the functions which manipulate the data. Okay, and data encapsulation leads to the important object-oriented programming concept of data. So once again, we have an example for data encapsulation. We have hash include IO string using namespace std function, class adder. You go with public, the adder int I equal to 0 and total equal to I. And similarly, interface to the outside world, we have void add num int number. Total equal to total plus number, and then interface to the outside world, it is int get total, return the total. And this is actually the public class which we are defining, and in the private class you define with int total. Okay, and similarly int main function added a dot add num 10, a dot add num 20, a dot add num 30. Okay. Finally you are going to print the total. So when you are going to compile it and run it successfully, you are going to get the total as 30 plus 20 plus 10, it is 60. So this add num as well as get total are public numbers which are considered to be the interfaces to the outside world, and the user needs to know about it to use the class. Okay, so total means you are going to get the class correctly, you are going to print the total in the, what you have the data encapsulation process. So these are the independent works. I've already posted them in the Google Classroom. Those members who have already joined in the Google Classroom will get to access the syllabus, materials and the independent works. So please complete them on time. Introduction to data structures and algorithm, stepwise refinement techniques, modular programming.